In this video, we'll be learning on how to convert inequalities in set builder notation and convert it into interval notation and a number line. Alright, so for this problem, it says convert the following sets of numbers into interval notation and a number line. So we're given the inequality in set builder notation. And what we want to do is convert it into interval notation and a number line. So whenever you start off in set builder notation, you want to make the number line first and then go to interval notation. So we have the number line right here. Negative infinity is going to be towards the left and positive infinity is going to be towards the right. We have the values -2 and 2. So we plot those points. Now all we have to do first is determine if these values are going to have a hollow point or a shaded endpoint. So you have a shaded endpoint whenever x can equal that value. When x can be exactly that value. And we represent that with brackets in interval notation. We have a hollow point whenever x cannot equal that value. And we represent that with parentheses in interval notation. So we have the inequality s is less than or equal to -2. So we have x is less than -2 and x is equal to -2. So since x can equal -2, it can be this shaded endpoint because x can be exactly -2. So we represent that with a shaded endpoint. Now, what about 2? We have the inequality x is greater than or equal to 2. So we have x is greater than 2, and then x is equal to 2. Well, since x can equal to 2, then we represent that with a shaded endpoint. X can be exactly 2. So represent that with a shaded endpoint. Now all we have to do is just shade in our interval where these inequalities exist. So we have x is less than -2. So if it's less than -2, it's towards the left. It's closer to negative infinity. -3 is smaller than -2, and -3 would be to the left of -2. So we shade in this region right here. Now we have the other inequality. We have x is greater than 2. If x is greater than 2, it means more towards the right, more towards positive infinity. 3 is greater than 2, and 3 is to the right of 2. So we shade in this region as well. So now all we have left is to convert it into interval notation. So we start off towards the left and then move towards the right. So we have negative infinity right here. And we just need to determine if we use brackets or parentheses for negative infinity. So anytime you have infinity, you always use parentheses. And the reason why is we use parentheses to denote that x cannot be exactly that value. Since infinity doesn't have any numeric value associated with it, yes, it goes on forever, but there's not an exact number for it. We know that 9 is 9, but infinity is just infinity. It doesn't have a number associated to it. It just goes on forever. So anytime we have infinity, we use parentheses. And then comma, and then we have the shaded in interval. So we move from negative infinity to -2. Now, we have a shaded in point for -2. We know that x can be exactly -2. So since we know that, we use the brackets. And then we have this big gap right here in between -2 and 2. So what do we do there? Whenever we have a gap in our interval, we use a union symbol to unite our intervals. It basically just bridges the gap. It shows that there's a gap there in our interval. So we use the union symbol. And then we have 2 to positive infinity. So 2 has a shaded endpoint, which means we use brackets. X can be exactly 2. And then comma, and then we go to positive infinity. Remember, infinities are always represented by parentheses. So that's your answer. So we have our inequality in set builder notation, and we want to create a number line for it and convert it into interval notation. So we have our number line. Negative infinity is going to be on the left, positive infinity on the right. The only value we're given was 3, so we put 3 on our graph. Now, we have to determine if 3 has a hollow point or a shaded endpoint. So we have the equation x cannot equal 3. So since x cannot be exactly 3, we use a hollow point to indicate that. Now all we have to do is determine the area where we shade in for the number line. So we have that equation x cannot equal 3. So x can be any value but 3. It can be 2.9, it can be 3.1, it can be any value as long as it's not 3. So negative infinity to 3 is going to be an area we shade in because it's not exactly 3. And then we also shade the right side of 3 to positive infinity. So now all we have to do is just draw the interval notation. So we have negative infinity. And remember, anytime we have infinities, we use parentheses and then comma. And then so that shaded region goes from negative infinity to 3. Now we use 3. Do we use brackets or do we use parentheses? Well, since x cannot equal that exact value of 3, we use parentheses. Now, since we have a hole in the graph, a value that x cannot be, it is a gap in the graph. So we have to use a union symbol. Even though it doesn't look like a big gap, it's still a gap in the graph. So you use a union symbol, and then we go from 3 to positive infinity. Since we know x cannot be exactly 3, we use the parentheses, and then 3, comma, to positive infinity, which infinities we always use parentheses. So that's your answer. So we have the inequality x cannot equal plus or minus 3. So let's draw a number line for that. So we have negative infinity towards the left, positive infinity towards the right. So we have that value plus or minus 3. So we have negative 3 and positive 3. And we have that equation x cannot equal plus or minus 3, which we can write that as x cannot equal negative 3 and x cannot equal positive 3. So since we know that x can't be exactly negative 3, we use those hollow points on negative 3. And the same goes for positive 3. X cannot be positive 3. So since we know that, we use a hollow point as well there. Now let's shade in the region. X cannot equal plus or minus 3. So x can be any value but plus or minus 3. X can be any value but negative 3 or positive 3. So we shade in the region negative infinity to negative 3. We shade in the region negative 3 to 3. And we shade in the region 3 to positive infinity, since it's not negative 3 or 3. Now all we have to do is draw our interval. So we start from left to right. We have negative infinity, which we always use infinities with parentheses. And then we have comma, and then it goes to negative 3. And then we know that x cannot be exactly negative 3. And we have a hollow point. So that indicates that we use a parentheses. Now remember, we have a hole in the graph. So we have to use our union symbol, since there's a value that x cannot be. So we use union, and then we go from negative 3, and we use that with a parentheses because of the hollow point, or just x cannot be exactly that value. And we go to positive 3. And since that has a hollow point, or a hole in the number line, we use a parentheses. We also have to use a union symbol there since there is a gap in our interval. So another union symbol, and then it's from 3 to positive infinity. And 3 has a hole in it, so we use the parentheses. And then infinity, we always use parentheses. So that's your answer. So we have our inequality there. So let's draw a number line first. So we have negative infinity towards the left, positive to the right. And we have our value negative 1, positive 3, and positive 5. So now all we have to do is determine if these values are going to have a hollow point or a shaded in point. So we have that inequality, negative 1 is less than x, and x is greater than or equal to positive 3. So we can split that inequality into two pieces. So we can say negative 1 is less than x. We'll do that one first. So since negative 1 is less than x, meaning x can't be exactly negative 1. If we plugged x's negative 1 into there, we get negative 1 is less than negative 1, which is not true. So it means x can't be exactly negative 1. So we use a hollow point right there. Then we have the other piece of that inequality, x is greater than or equal to 3. So since it has that equal to part, x can be equal to, greater than, or equal to 3. It means that 3 is going to have a shaded in value because x can be exactly 3, which we plug that in here, and it makes it a true statement. Because we have 3 is greater than 3, which is not true, but we do have the 3 equals 3 part, which is true. So we use that shaded in point there. And then we have x is equal to 5, which x can be exactly 5. So that's a true statement. So we put that with a shaded in point. Now all we have to do is shade in our regions for our number line. So we have -1 is less than x and x is less than or equal to 3. So x is going to be in between -1 and 3. So we shade in this area right here. And then we have the equation x is equal to 5, which x is just exactly 5. There's no region to shade. We can't shade 3 to 5 because that's not the interval that we were given. We were given x is equal to 5, so x is exactly 5. It doesn't go from 3 to 5. Now, we do need to fix up our number line because we didn't use any of the infinities, so we can clean it up and get rid of the infinities. So it should be something like this. Now, all we have to do is draw our interval. So we have -1 to 3. And we need to use our parentheses for -1 because x can't be exactly -1. And we use our brackets for 3 because x can be exactly 3. We have a shaded in point for 3, so we use brackets. We have a hollow point for -1, so we use parentheses. Now, what about this little gap right here in our number line? We use that union symbol. And we have 5. Now, anytime you have a single value, so notice that it doesn't go from 3 to 5. It goes to 3, and there's a gap, and then it goes to exactly 5. Anytime you have a single value in your parentheses or brackets, use braces. So that's going to be your interval. Now, a way to memorize and speed up the process of converting set builder notation to number line notation and interval notation is whenever you have a shaded in point, is going to be whenever you have an equal sign, less than or equal to sign, or greater than or equal to sign. And then for your hollow point, you're going to have that whenever you have a does not equal, a less than, or greater than. So let me show you that this works. So we have the number line. So we have negative infinity, positive infinity. And then we have the value -1 and 5. So -1 has an equal to part. It's right here. It's less than or equal to right there. So we're going to use a shaded in point right there. And then we have x is less than or equal to 5. So it doesn't have that little symbol, that equal to symbol. So we use the hollow point according to that table I made. So the region we're going to shade is going to be in between -1 and 5 because of that inequality. -1 is less than or equal to x, and x is less than 5. So it has to be in between -1 and 5 according to that inequality. So we shade in this area. So we need to change up our number line because we shaded in only -1 and 5. So we can erase the infinities. Now, all we need to do is draw our interval notation. So if you recall, whenever we have a shaded in point, we use brackets, and whenever we have a hollow point, we use parentheses. So we have -1, 5. And for -1, we're going to use brackets because we have a shaded in point. And for 5, we're going to use parentheses because we have a hollow point. And that's your answer. So we have the inequality negative 5 is less than x, and x is less than or equal to 0. So let's draw a number line. So we have negative infinity towards the left, positive infinity towards the right. So we have the values negative 5 and 0, so we plot those. We have negative 5 is less than x, so no equal to part, so we use a hollow point there. Then we have x is less than or equal to 0, so we have an equal to part there, so we put a shaded in point there. Now all we have to do is shade in our region. So we have negative 5 is less than x, and x is less than or equal to 0. So it means it's going to be in between negative 5 and 0. That's where x is going to be in between. So we shade in this area. Now all we have to do is write that in interval notation. But first, let's clean up our number line since we didn't use the infinities. So all we have to do is draw an interval notation now. So we have negative 5 and 0. Negative 5 has a hollow point, so we use parentheses there. And 0 has a shaded in point, so we use a bracket there. And that's your answer. Now, for this inequality, we have our number line. Negative infinity, positive infinity. Then we have the value 3, which was given to us. Now, 3 has an equal to part of the inequality. It's less than or equal to. So since it's equal, x can be exactly 3. So we represent that with a shaded in point. Now, with x being less than or equal to 3, we have x is less than 3 and x is equal to 3. We already have the equal to 3 part labeled. So the x is less than 3 is to the left of 3. That's the area we shade in. Now, all we have to do is draw our interval. So we have negative infinity to 3. Negative infinity is always going to be represented with parentheses. And 3, we have a shaded in point. X can be exactly that value. So we represent that with brackets. And we also need to fix our number line because we didn't use that positive infinity component. We didn't use the right side of 3, so we can erase that. So that's going to be your answer. Now, for this inequality, we draw a number line. We have negative infinity, positive infinity. And we have the value negative 3 given to us. And negative 3 has an equal to sign, a part of that inequality, so we represent that with a shaded in point. And we have that inequality, x is greater than or equal to negative 3. So we have x is greater than negative 3 and x is equal to negative 3. So we already have x is equal to negative 3 already labeled with that shaded in point. So if x is greater than negative 3, that means more towards the right, more towards positive infinity. So we shade in this region. So all we have to do is draw that into interval notation. So we have negative 3 to infinity. So negative 3, x can be exactly that value. It has a shaded in point, so we represent that with a bracket. And infinity, we always use parentheses. So that's your answer. But we do have to erase that negative infinity component of the number line. So we erase that, and then that's your answer. Final answer. So we have that equation x cannot equal 5. So let's draw a number line. And we were given the value 5, negative infinity towards the left, positive to the right. And we know that x cannot equal 5. So there's a does not equal part to that. So we use a hollow point to represent that. And x can be any value but 5. So we shade in negative infinity to 5 and 5 to positive infinity. Now, all we have to do is draw our interval notation. So we have negative infinity and 5. So infinities, we always use parentheses. And since 5 is a hollow point, we use parentheses. X can't be exactly 5. Since there's a gap in our number line, we use a union symbol. Even though it's a small graph, we still use the union symbol. And then parentheses, 5 comma positive infinity. And then we use another parentheses for our infinities. So that's your answer. So for this inequality, we have x cannot equal negative 1. So let's draw a number line. And we get the value of negative 1. So let's put a value for that. And we get a cannot equal sign. X cannot equal -1. So since we have that, we know that cannot equal signs, we represent that with a hollow point. So x can be any value but -1. So we can shade in negative infinity to -1 for our region. And we can shade in -1 to positive infinity. So in interval notation, it's going to be negative infinity, comma -1. And we can represent negative infinity with a parentheses and -1 with a parentheses, since -1 has a hollow point. So we have a little gap in the graph. We have a hole in the graph. So we need to unite that with the union symbol. And then we have -1, comma, positive infinity. -1 has a parentheses because it's a hole in the graph, and infinities we represent with parentheses. So that's your answer. So what about this inequality? We have x cannot equal 3, comma 4, which we can write as x cannot equal 3 and x cannot equal 4. So let's draw a number line. So we have the values 3 and 4 given to us. So x cannot equal 3. Anytime we have a cannot equal sign, we represent that with a hollow point. And we have to do the same for 4, because x cannot equal 4. Now, we have to shade in our regions. Negative infinity to 3 is one of the regions. The inequality states that x cannot be 3 or 4. So it can be any value but 3 and 4. So we can also shade in the region in between 3 and 4. And we can also shade in the region from 4 to positive infinity. So let's start from left to right. We have negative infinity, comma 3. Infinities we can represent with parentheses. And since 3 has a hollow point, a hole in the graph, we have to represent that with a parentheses. And since there is a hole in the graph, we have a point where x cannot be a certain value. We use a union symbol to unite those regions since we have a gap there. So union, and then comma, and we have the values 3 and 4. So we represent 3 with a parentheses like we did before. And 4 also has a hollow point, so we represent that with a parentheses. Now, we have a gap at 4, so we have to use the union symbol. So we use it once more, and then 4, comma, positive infinity. So 4, we represent that with a parentheses like we did before, and then infinities always have parentheses. So we use a parentheses there, and that's your answer. Now, for this equality, we have x cannot equal 0, comma 2, which we can write as x cannot equal 0 and x cannot equal 2. So let's draw a number line. So we have negative infinity to the left, positive to the right. We're given the values 0 and 2. So we have 0 and we have 2. So x cannot equal 0, and anytime we see a cannot equal sign, we use that with a hollow point to represent that on the number line. X cannot equal 2, so we do the same thing there. Now, all we have to do is shade in our regions. X cannot equal 0 or 2, so it means it can be any value but 0 or 2. So we shade in the region negative infinity to 0, we shade in the region 0 to 2, and 2 to positive infinity. Now, all we have to do is write this in interval notation. So we have negative infinity to 0. Infinities are always represented with parentheses, and 0 has a hollow point, so we represent that with a parentheses. Now, we have a gap at 0, so we need to use a union symbol. So we use a union symbol, and then we have 0 to 2. 0, we use the parentheses, and 2 also has a hollow point, so we use the parentheses there. And at 2, we have a gap, so we use that union symbol again. Then we have 2 to positive infinity. So 2, we use a parentheses for that, so we use it again. And then infinities are always represented with parentheses. So that's your answer. So for this inequality, we have x cannot equal 2, comma, negative 2. So we can write that as x cannot equal 2 and x cannot equal negative 2. So for our number line, we have 2 and negative 2. So we have negative 2 and 2. So at negative 2, it's going to have a hollow point because we have that cannot equal 2 sign. And then at 2, it's going to have a hollow point because it has that cannot equal to sign. So x can be any value but negative 2 and 2. So we shade in the region negative infinity to negative 2, region negative 2 to 2, and 2 to positive infinity. So we're going to start off from the left. We have negative infinity, comma, negative 2. Infinities always have parentheses, and at negative 2 it has a hollow point, so we use a parentheses there. We have a gap at negative 2, so we need to use the union symbol. And we have negative 2, comma 2. Negative 2 we used before has a parentheses, and then at 2 it also has a hollow point, so we need to use parentheses there. And then we have a gap in the number line, so we need to use a union symbol. And then we have 2, comma, positive infinity. So 2 is going to have a parentheses, and infinities are going to have parentheses. So that's your answer. So for this equation, we have x cannot equal 0 and x cannot equal plus or minus 4. So we can write that as x cannot equal 4 and x cannot equal negative 4. So let's draw a number line. So we have negative infinity, positive infinity. We have the values 0, 4, and negative 4. So we know that x cannot equal these values, so we can write a hollow point on each of these values. So we need to shade in our region. X can be any value but negative 4, 0, and 4. So we shade in all those regions. Negative infinity to negative 4, negative 4 to 0, 0 to 4, and 4 to positive infinity. So our interval is going to be negative infinity, comma, negative 4. Infinities always have a parentheses. Anytime we have a hollow point, we use a parentheses. And we have a gap, so we need to use a union symbol. Then we have negative 4 to 0. Negative 4 has a hollow point, so that's a parentheses. And 0 also has a hollow point, so that's a parentheses. And then we have a gap at 0, so we use a union symbol. And then we have 0, comma 4, which we represent 0 with a parentheses and 4 with a parentheses since they have hollow points. Then we have another gap, so we use the union symbol there. And then we have 4, comma, positive infinity. So we use a parentheses for 4, and infinities we use parentheses. So that's your answer. So we have the inequality x is less than or equal to negative 1, and we have x is greater than or equal to 1. So let's draw a number line. So we have the value negative 1 and 1. So we plot those in our number line. So we have x is less than or equal to negative 1. So we use a shaded point at negative 1. And the same thing goes for 1. We have x is greater than or equal to 1. So we represent that with a shaded in point. Now all we have to do is determine our regions where we shade in. So we have x is less than or equal to negative 1. But we're really worried about x is less than negative 1. We already did the equal to part. So x is less than negative 1, so that's towards the left, towards negative infinity. So we shade in that region. And the same thing goes for x is greater than or equal to positive 1. X is greater than 1 is what we're worried about since we plotted x is equal 1. So x is greater than 1, so that means more towards the right. So we shade in 1 to positive infinity. So our interval is going to be negative infinity, comma, negative 1. Infinities, we use parentheses. And at negative 1, we have a shaded endpoint. So we use brackets. So we have a big gap between negative 1 and 1. So we have to use the union symbol there. So union, and then we have positive 1, comma, positive infinity. So for 1, we have a shaded endpoint. So we use brackets there. And for infinities, we always use parentheses. So that's your answer. So for this problem, we have x is less than 3, and we have x is greater than or equal to 2. So let's draw a number line. So we have the values 2 and 3. So x is greater than or equal to 2. We know that's going to be a shaded endpoint. x is less than 3, we know that's going to be a hollow point. So we have to do a shade in our regions. We have x is less than 3. So x can be any value to the left of 3. So we shade in 2 to 3, and we also shade in negative infinity to 2. Now we have x is greater than or equal to 2. We already plotted x is equal to. That's that shaded endpoint. So we're really worried about x is greater than 2. So we shade in 2 to 3, which we already shaded in. And notice at 3, x can be 3 and fit this inequality. So if x is equal to 3, and we put that into that inequality, we have 3 is greater than 2. That's a true statement. So now that we have an extra inequality, and it's true, we have to shade in 3 now. It might not fit this inequality, but it fits this one. Notice that it says x is less than 3 or x is greater than or equal to 2. So we have to shade in 3 now, since it fits the other inequality. So x is greater than 2, so we have to shade in 3 to positive infinity as well. So we have the whole number line shaded in, and each point have shaded in points. So all we have to do is write our interval notation. So instead of doing negative infinity to 2 and then 2 to 3 and then 3 to positive infinity, we don't have any union. So there's no point in doing that. We can just write it as negative infinity to positive infinity, because x can be any value. So all we have to do is put our parentheses, and that's your answer. So we have the inequality x is less than or equal to negative 3, or x is greater than 0. Let's draw a number line. So we have negative 3 and 0. So let's plot those values. So at negative 3, we're going to have a shaded endpoint, because x is less than or equal to negative 3. And then we have x is greater than 0. So we have to put a hollow point there, because there's no equal to part to that greater than sign. Now we have to do a shade in our regions. So we have x is less than or equal to negative 3. We already plotted x is negative 3. X is equal to negative 3. That's that shaded endpoint. So we're really worried about x is less than negative 3. So if it's less than, it's to the left of the point. So if x is less than negative 3, it's going to be negative infinity to negative 3. And then we have x is greater than 0. So if x is greater than 0, it's to the right, towards positive infinity. So we're going to shade in that region, 0 to positive infinity. So in our interval notation, we have negative infinity, comma 3. Infinities are always going to have parentheses, and negative 3 has a shaded endpoint, so we use a bracket right there. Then we have a gap in our interval, or in our number line, we have negative 3 and 0. We have a gap there, so we have no shaded in part, so we have to use a union symbol. So we have union, and then 0, comma, positive infinity, and then we have a hollow point at 0, so we have to use parentheses, and at positive infinity, we have to use a parentheses as well. So that's your answer. So we have the inequality x is less than or equal to 5, or x is equal to 6. So let's draw a number line. So we have the values 5 and 6. So for 5, we have x is less than or equal to 5, which we know that's going to be a shaded endpoint because it has an equal to part. Then we have x is equal to 6. Since it has an equal to part, we represent that with a shaded point. So all we need to do is draw our shaded in our regions for our number line. So we have x is less than or equal to 5, but we already did the equal to part. We already put the shaded endpoint for x is equal to 5. So it's really concerned about x is less than 5. Since x is less than 5, that's going to be to the left of 5. So it's going to be in between negative infinity and positive 5. And then we have x is equal to 6, which we already plotted with the shaded endpoint. So our interval is going to be negative infinity, comma 5. infinities, we always use parentheses, and at 5, we have a shaded endpoint, so we use a bracket. Then we have a gap between 5 and 6, so we have to use a union symbol. Do the union, and then 6, since we have 6, just 6 and not 6 going to something, we have to use braces. And that's your answer. So we have the inequality x is greater than 2, and then we have x is equal to plus or minus 1. So let's draw a number line. We have negative infinity, positive infinity. We have 2 and plus or minus 1. So we have negative 1, 1, and 2. So let's start off with 2. We have x is greater than 2. Since it has no equal to part, we represent that with a hollow point. Then we have x is equal to plus or minus 1. So since it has the equal to part, we represent negative 1 with a shaded endpoint and positive 1 with a shaded endpoint. So we need to shade in our regions. Now the only inequality we have is x is greater than 2. So if x is greater than 2, it's to the right of 2. So to the right of 2 is 2 to positive infinity, so we shade in that region. Now all we have to do is draw our interval notation. So we have, if we start from the left, negative infinity is not shaded in. Negative infinity to negative 1 is not shaded in. So we can erase that. So we start off at negative 1. So since we start off at exactly negative 1 and not negative 1 to 1, since it's one single value, we have to use braces. And then we have a gap from negative 1 to 1. So we have to use a union symbol. And then we have 1, and there's not 1 going to 2, it's just 1. It's just 1, 1, I guess. It's one single value. So we have to use our braces here again. And then we have a gap from 1 to 2. So we have to use a union symbol there as well. So then we have 2 comma positive infinity. Now at 2 we have a hollow point, so we have to use parentheses. And for our infinities we use our parentheses. So that's your answer. Now we have the inequality x is greater than negative 3, but x is less than 3, or x is equal to 4. So let's draw a number line. So we have negative 3, 3, and 4. So let's plot those values. So negative 3 is less than x. So since it has no equal to part, we have to represent that with a hollow point. And the same goes for 3. We don't have an equal to part for x is less than 3. So we have to use a hollow point there. And then for the equation x is equal to 4, it has an equal to part, so we use a shaded endpoint. Now we have to shade in our regions. So we have negative 3 is less than x, but x is less than 3. So it's in between negative 3 and 3. So we have to shade in that region. And that's all the regions we're going to shade. So we don't have negative infinity to negative 3. We don't have that shaded in, so we can erase that. And then we have negative 3 to 3 shaded in. And then from 3 to 4, we have 2 points. So we keep that there. And then we have 4 to positive infinity. We can erase that region, since we're not using it. So all we have to do is convert this to interval notation. So we have negative 3, comma 3. Negative 3 has a hollow point, so we use the parentheses there. And 3 has a hollow point as well, so we use parentheses there. Then we have a gap in our interval, so we have to use the union symbol. And then we have 4. So since it's a single value, we have to use braces. And that's your answer.